Okay, good morning, everyone. Today, as you see, I'm in the class, and also I took a movie and posted over GroupMe, so you can see how's, if you want to attend the in-person, how's your sitting would be. Almost, you cannot sit in the half of the class. I think the capacity right now is about 20, or exactly 20 with me, 21. So, but today morning, I think it was cold too, so nobody came, so it's just me in the class. You don't see I'm wearing a mask because it's pretty safe. But take care of your health. In some schools, people didn't pay attention enough, so they shut down some schools. I heard that in Indiana, some schools are closed. Also, I know yesterday, 200 students in Auburn, which is my previous school, had a positive result for the COVID-19. Also, 50-something students in Georgia Tech was positive too. So just take care a lot. And in case you want to attend in-person classes, you need to wear mask and be very careful. Also, we have so many sanitization things here, like I think wipes, alcohol, whatever. So they try to follow strict standards for the in-person option, but again, you don't have to come if you don't feel comfortable, and especially our class is early morning. When we get to the colder time, I'm not sure if you can wake up that much early, but anyway. So again, today I also started a little late. I waited for most of you to join, but please on time for the next classes. I don't wait for from next week. I don't wait for the people who was late, but I save all of the sessions so you can later just watch the videos, and in case you have questions, you can reach me for the question that you might have. Again, my office hours are online, and I will post the Zoom link over announcement part of your Moodle. So if you missed any email from me, or I didn't post in GroupMe, you can check the announcement. And the announcement of your Moodle, I put the most important information. But also I use GroupMe for fast communication, and which is less formal. So is there any question from the previous session? Like syllabus, materials, anything? By the way, this semester, right before this semester, we had the issue. I tried to use Cloudera technology for Hadoop and Spark. They suddenly stopped support. So it's the reason I spent a lot of time to change the materials. But anyway, we still have Horton Hadoop platform, and also I want you guys to make your hands dirty with the Horton because there's a learning curve for learning Hadoop. Then we go to other tools like Amazon AWS. That's much more updated, but the reason I didn't start Amazon early in the semester because Amazon actually charges. But for students, they give you $100 credit. But those 100 credits are rather you guys do your homeworks or project, not used for learning. And sometimes, which is like based on my experience, almost all the students get overcharged. For example, if you just forget to turn off the AWS, suddenly Amazon charge you for $1,000. Usually they forgive, but I cannot guarantee that they always forgive. So again, when you want to go to AWS, you should have a strong background and knowledge, and you need to know how to handle it. Otherwise, if you just forget to turn it off, they charge you too much. So we hope that again they forgive us, but anyway, so hopefully we have enough time that we go through other tools like Amazon AWS, but at the early beginning, I think Horton Hadoop platform is more than enough. We learn how to do coding with Python and how to run some script in Hadoop. Like those scripts are similar to SQL Server. So it's the reason I told you guys to try to have at least a review over SQL Server, MySQL, those kind of knowledge. There is so many online platforms. Though you don't need to be a SQL expert, you just need to know some basics. So any online courses that you spend like 4 or 5 hours in total, it should be more than enough. Also for Python part, please review our previous class in analytics programming, and it should be more than enough too. So in this course, basically, we don't evaluate your knowledge in Python or SQL, but you need to have those knowledge to be successful in this course. Anyway, let's go to slides. Yeah, monitor is a little weird today, so let me see. The funny thing, right now, it just shifts between my view and your view. I want both of us see this thing, so just a moment. Okay, could you, let's see. Could you guys see my PowerPoint?
Yeah.
Okay, cool. I cannot see that, so let me see what can I do. Probably I need to change my laptop position. I'm not sure. There's a weird technical issue right now. Let's see. But it's hard if I cannot see that. How can I talk? So let me see. Just a moment, please. I'm trying to open another one. What about now? Could you see my monitor? The PowerPoint? Do you see the figure? I mean, now I'm showing the 4 V's of big data. Okay.
Yeah.
Okay, cool. So that's, I'm not sure. There's some weird technical issues today. So let me just close this one. Okay, we have talked some basics of why we have to use distributed file systems, and again, the main issue is that we have too much of data in different variety, volume, velocity, and also is not safe and practical to just have a big supercomputer. The reason was, let's say there is any power issue. You don't, let's say Amazon just have one big data center, and in case they have a power issue, they get bankrupt. So they need to have multiple center to have redundant copy of data. So in case just they use even half of them, they are still, it can be operational. So let's just keep going. All of us know that data is valuable. Basically, whole of your major on the valuable information that you can get from data is the reason you're studying business analytics. So there is some examples that we had in previous semesters, like which kind of product recommendation, how to predict demand in different seasons and times, how to have the better marketing analysis, fraud detection, and other cases. So for getting value, we need to process the raw data. So again, data is getting bigger every day or every second even. So we need to scale our data storage and processing power. So these are the main challenges that people expose early in the development of the computer systems. This problem was like from 1950 even, like it's getting like 7 years. It started even 7 years ago. Look at this picture. This is 5 megabyte IBM hard disk. I think this PowerPoint is about 5 megabytes, or 5 megabytes is almost nothing. When you watch a movie, the movie could be 1 gigabyte or 1,000 megabytes. And the annual cost was $35,000 per year. Very expensive. But technology evolved. Nobody could imagine what happened like 70 or 60 years later. But right now, even in your pockets, you might have some pen drive with terabytes of capacity, which is super cheap. These are some average costs of data storage. 1997, like 2 gigabytes was like $160 almost. In 2004, 200 gigabytes was just $1. And 2015, which is like 5 years ago, is almost a quarter. And for 2020, I mean, we should see what happens by the end of the day, but it's just, again, much cheaper than before. When you store the data, you need to process it. So again, your major is business analytics, and you need to analyze data to get some value. And the way so you need to read the data, transfer the data from storage to the models, and do your prediction or other things, or some other analysis. But the transferring rate is one of the bottlenecks. Look at the speed. In 1997, this transferring rate was about 17 megabytes per second. In 2004, was about 57 megabytes per second. So if you're in 2004, if you wanted to read your hard drive, it took about 1 hour. In 2015, 3,000 gigabytes or 3 terabytes. The transferring rate just got almost 4 times faster, but the capacity 15 times more. So it takes about 4 hours to read 3,000 gigabytes of the data. So as you see, transferring rate or reading rate, whatever you can consider it, because transferring also is bottleneck after reading your data from hard drive, is a big challenge. So what can you do when your transferring rate is very low? You can distribute you can have redundant copies of your data in different systems, or we call it nodes from now, and just read it at the same time. For example, you want to process the data of students in Clark University, you can divide your data in 4 different locations and assume that the data are not dependent on each other. When you read it in 4 different nodes, your reading process or transferring rate is 4 times more. So one of the ways that you can handle the transferring rate bottleneck, because as you see in the previous slide, the capacity cost is very cheap. So you can have redundant copies. So there's not that much of cost, but again, data read time is a bottleneck. So you can, instead of having just 3,000 gigabytes, you can have 4 different copies. It will be 12,000 gigabytes. But instead of 4 hours, if you divide in 4 nodes, your reading time is just 1 hour, because you have 4 multiple copies and you can read them independently. So your reading rate is much more. So what can we do? We can put all of the nodes in the one monolithic computing center, or you can assume supercomputer, whatever. And you can increase the processor, you can increase your RAM memory, but there is some limitation. Is a cost and scalability. So there is some supercomputers in the US or around the world, they're as large as a building. But as you see, scalability here, you might say, okay, instead of 1 building, we make 2 buildings, or like make that buildings larger and larger. You might handle it in some ways, but does anyone remember what I just said? What could be another limitation for having just a monolithic computing center? I was thinking about feasibility and being safe. I mean, increasing the safety and reliability, right? I thought, oh, some of you just answered. Let me read the answers. Yes, flexibility and also security issues. Yeah, there is some, you could face some limitation. And like, if instead of like, let's say your supercomputer is 1 floor, you now make it like 10 floors, still you have 1 big large center, but yeah, you have some flexibility issues, maintenance is harder, and also security issues, yes. Let's say, I'm sure that you know Khalifa Tower in Dubai, or Willis Tower, or World Trade Center. Let's say we change the World Trade Center in New York to a computing center for Amazon. Let's say Amazon buy it, and you know that's a large building, and just turn it to like a computing center. The issue is that, again, I said, let's say the New York power just went out, or some crazy guy hit that tower with an airplane. So Amazon doesn't have any other centers. They get bankrupt. So again, it's very expensive to make that building to a computing center. There is some flexibility issue, but it's not even a good decision. Even if you have, like Amazon, you have unlimited budget, but I mean, and you can buy the largest building in the United States. Again, it's not safe to do that. And it's not, and you know, for designing a computing center with that much power, you need to spend a lot of money for design and buying specific equipment for your specific need. So it's much more expensive. But with distributing with the distributed computing, let's say, you don't have to buy a large building. You don't need to design for yourself. You can use the common frameworks, common high they are still expensive. They are not cheap, but they are more commercialized and everybody is using. So instead of one large building with primary design, Amazon can buy 100 buildings around the US with the common frameworks that everybody use and distribute the computing powers between them. It still is very fast. And they can just have, instead of one copy in the one building, they can have 50 copies. And as we just said, capacity is very cheap. So buying, making more copies is a little more expensive, but it's not too expensive. So with the common frameworks that already all the people is using, is much cheaper than you hire somebody to just design for yourself. So it might be reason Rolls-Royce, or not even Rolls-Royce, there is some, let's say you buy a car that just designed for 100 vehicles, one specific type of cars, let's say Mansouri or other people. So they have a small workshop that they make car for you. They are millions of dollars. But if you buy a Toyota Camry, or even if you buy much more expensive, if you buy a Tesla or whatever car, since they're make it for millions of people, they already have a one design. There are still good cars. Toyota is a really good car. Tesla is a really good car, but they are much cheaper because they are common cars in the United States. So this is, in here you can see the general distributed computing processing pattern. As you see, you have a computing node, so you need to copy your data from storage to computing node, then you process in the computing node, and just return it back to the storage location. And it happens over a cloud, because in distributing processing or distributed computing processing, you have centers around the world. So you have a cloud that have a copy of your data, and you do computing in those clouds. So we just talk about the data processing bottleneck. Oh. So handling this much of process, this redundant copies, is kind of challenging. You know, how you tell the nodes to focus on just a portion of your data. Again, I'll talk about Clark students. Let's say we upload the Clark students' data over Amazon distributed computing centers. So, and you run a Python code over Hadoop. So what happens, the system should figure out, let's say they use 10 centers to process Clark students, maybe one center for School of Management, one for, Geography department, another one for the software engineering department, and so other different departments. So distributing the data, distributing computing, and how to distribute, how to manage, and how to handle the error. These are the main concepts. Let's say we want to process data, like students who are in the School of Management. We want to process their data, and Hadoop just told a node in Chicago to process those students' information. Let's say they lost the connection to Chicago, what happens? They still want to get the results, so maybe a Hadoop system of Amazon AWS would tell to the system that now I use New York node, computing node, to handle the School of Management. So you have distributed computing, your data is, you have a redundant copies of your data in multiple locations, and you might have errors. How to handle those errors and return back the result is really challenging, and it's the reason Hadoop is designed. So actually, it comes from a paper, a technical paper published, I think it's getting near like 15 years ago by Google. And that time, Google was not that much large. So first Yahoo picked the paper, and they were the first developer of Hadoop. Then, but later Google also took a significant part, and now is a major developer of Hadoop system is Google. So, what is the Hadoop? If it's under, first of all, now it's under Apache project, and the main goal is having a scalable and economical data storage and processing. We have distributed and fault-tolerant characteristics. Again, as I said, you processing multiple center. What happens if you have errors in some of them? And we want to harness the power of industry standard hardware. So we don't want to design hardware for our need. We want to use the common standard hardwares. They are still very expensive hardwares, but since they are standards of the industry, they are much cheaper than designing by yourself. So Hadoop has 2 or 3 main components. The first is storage. So you need to copy your data in the multiple location. We call it Hadoop Distributed File System, or HDFS. Then you need to do MapReduce. MapReduce means how to do parallel processes and how to return back all the results from different locations. And the last one is the infrastructure. So you need to have multiple nodes and just manage it with your Hadoop system. So there is some general terms that you need to just need to know. So a collection of server running Hadoop software, we call them cluster. So cluster is basically collection of server, and if you forgot the server means just a computing unit that have a storage and processor to process your data. And they followed the Linux structure for designing Hadoop. And if you're good in Linux, probably many of the terms make sense a lot. And each cluster could contain several thousand nodes. Again, units of Hadoop are nodes. They are name nodes and data nodes that I explain later. And also, the other good thing, you can, every time you need more computing or storage needs, you can just buy more nodes and just add to your clusters. So again, one of the good characteristics of Hadoop is fault tolerance. It comes from the redundant copies that you have around the world, or multiple locations that you have. So anytime you see issues, Hadoop just can shift the process from one node to another node, or one cluster to another cluster, and just take care of the failures. So in the Hadoop, usually the data unit is in 100 megabytes or larger. And we use it for multi-gigabyte files. I mean, it could be just from 100 to, like, let's say some gigabytes. And it's just increasing based on how technology evolves. The structure of HDFS, which stands for Hadoop Distributed File System, is based on Unix file system. So later, when we do some codes, there is some similarity with the Unix. If you have some Unix experiences, coding Hadoop could be very easy for you, but no worries if you never had Unix experiences. I teach you everything that you need for file management in Hadoop. So this is like a very small Hadoop cluster. As you see, we have a master node and slave or data node. Master node manages the metadata and slave nodes. Metadata is basically description of your data and the location. So basically, master nodes knows where are your data, which data nodes has which part of your data, and just basically master node manage data nodes. And the more common names is the old name was master and slave, which I'm not a fan of them. The more modern names are name node and data node. So especially when you want to install Apache Hadoop on your system, you can see that, especially in the Windows, you need to make a folder for your name node and another folder for data node. So basically, I'm not sure if you already started to install it on your system, but you can see that you need to specify folders for each of them. So these are basically, you can understand what could be inside those folders. Also, we might see so many command lines. They are somehow similar to Linux command line, like mkdir is for making new directory. Cat is for printing. Also, we use nano too. Nano is for just showing what is inside the text file. Again, no worries. I'm just reviewing, generally reviewing them. So for each of them, we have a lab, and we have some hands-on experiences. So no worries about them. Also, in this course, again, as I said, you can install on your system, but the thing that I teach you is through Horton data platform, which is already installed in a visual platform. In that one, you can see something similar to basically a graphical interface. So even you can do most of this one without coding. You can copy, paste, make queries, those kind of things without even using command line. But because Horton did us, the graphical interface of Horton is Ambari. In the Ambari, you don't need to make them, but it's good to learn because you know, this is for learning purposes. Maybe when you got a job, you need to work in the command line. So the graphical interface is for more general purposes, but if you need some specific task, you need to learn how to do in the command line. Basic command line is just for more real cases because it's very expensive to make a graphical interface for all the commands. Those interfaces are mostly for most common tasks. It still is very good, but those graphical interface usually doesn't cover everything. Even for Windows, Windows or Mac OS in graphical interfaces, almost you can do everything. But if you're doing a very advanced jobs, those interfaces are not enough. You need to do some command prompts, like type in commands by yourself. So just let me go. So let's see how MapReduce works. As I said, MapReduce in the basically is the methodology behind Hadoop. Mapping part just meaning that identifying or dividing your job in different nodes. So you have a big data, and that data is copied multiple times. But since you want to do pair processing, you ask each node to just process a part of your data, not whole of your data. So let's look at this video. Last time that I asked a student, they couldn't see, let's see. They couldn't hear the voice. Hopefully this time you can hear it. So let me see. So if you couldn't hear again, I mean, because yesterday students had issues, please watch the video later. Basically here we want to sum up the cards. We basically pick some random cards and we want to sum up the cards numbers. So we we make multiple copies of the cards and give it to your friends, but each friend just focus on certain number of cards, not all of them, and they do pair processing. So let's see if you can hear it in just a 1 minute video. If you couldn't, please watch it later so you can have the video, the voice. Okay, let's see. So first of all, could you hear the voice? Or you couldn't hear anything? Let's see. I'm not sure what's the issue, but there's some from yesterday I had the issue when I play a video on YouTube, you couldn't hear that, but I put the link in your PowerPoint, so later you can hear it. Basically, here we had some random cards. We make a copy, same copy, and gave it to 4 students. Asked them to, and then they shuffle based on the, or sort based on the card types. So this is map plus sort or shuffle part. Basically, in each node, you just focus on certain part of your data and do calculation. In the reduce part, we get the calculation from all the nodes, or here are 4 types of students, back to our report sheet. So basically, again, this is the technology or methodology behind the behind the Hadoop. First, you map your data in different nodes. Again, mapping means focusing on certain part of your data on the nodes that you pick. Then we have a sort or shuffle. Basic. It depends. Sometimes you don't have to sort them, but basically you sort your data or shuffle. Here, when we shuffle based on the type. So we just set each type on in each location. And reduction part, we just sum up the numbers in the cards. For example, 2, 3, 7, and A or 1. So, but A doesn't have any numbers, so 732 is 12, so heart is 12. Same for spade. So for a spade, we just have 8 and 6. So 8 plus 6 is 14, and same for the others. So again, this just told you how Hadoop works with the MapReduce. Basically, first map the data different nodes, calculation, reduce multiple calculations to just one report. And we do Python code for that. So later you learn how to use Python to code MapReduce. Again, the benefits of simplicity is very simple. You know, you already have multiple copies. Tell each node to just focus on certain part of the data based on the copy that they have. Also, if your data is larger and larger, you can just add more nodes. So you can easily scale your computing power. Here is another example. So here we have order ID, employee ID, and sale. We want to see what is the total sale of each employee. Again, these are very small problems. And in the real cases, our calculation is much more complicated. But here, just a small examples to just let you know how it works. So as you see, Alice has 4 different sales. Bob has 2. Diana has 2. Carlos has 2. So basically, we want to just sum up the result. The first part, as you see here, is mapping. So we already had 4 copies of data, and we had 4 nodes. We told each node to just focus on the section of the whole data. So as you see in the first node, we have Alice and Bob. In second, we just have Alice, and second, we have Alice, Carlos, and Diana, and the last one, Carlos and Diana. Then we have 2 reduce nodes or tasks. Basically, as you see, we sort Alice information in one part, Carlos, Bob, and Diana. Now the data is shuffled and sorted. And the last one, just reducing the results to the report. As you see, reduction here doesn't mean like minus in the like mathematical reduction, just meaning that you have results in everywhere. We just reduce all of them from everywhere in just one location. Or instead of reduce, maybe you can say aggregation task. But I hope you get the point. So here, after sorting, we know that for each employee, the key part is their name and the value is their sale. The key here comes from some SQL concept, which is how to identify records based on specific information. So it's the reason they pick the key value. So keys are the names and the sale is the value. So we aggregate or reduce the information based on the keys. So Alice has 12,000 sale, Carlos 1,500, and same for the others. I hope you got the point. So again, let me just summarize it. First, we map our data. We already had 4 nodes, and each node had a complete copy. So as you see in each node, we just work with the 2 records. It doesn't mean that in that node, we just have 2 records. Basically, in that node, we have all the records. But since we want to do faster processing, we just like Hadoop told that node, just focus in that 2 rows and save for the other nodes. Then we shuffle based on the key value, which is their names. And finally, we reduce or aggregate data, which comes from summing their values. And this is the result. Any questions so far? I have one. I'm not sure if I have a question or not. No. Okay. But actually, we do MapReduce coding by ourselves. So I just want you guys to know what is the overall process. But later, we use Python code to do MapReduce. So no worries. So I just want to go faster because there's so many slides. So let's see. There is 2 MapReduce kind of architecture. One of them is you have a master node and a data node, and master node just divide the task and let them work with that. There is a more advanced structure that comes from Yarn. Yarn stands for yet another resource negotiator. I don't you guys know what Yarn stands for. Basically, it's a resource negotiator. It just add an application node. So for each process, you have application node, then we have master and slave or data nodes. Basically, master node have the metadata and manage the data node or the slave nodes. And you do all the calculations on the data nodes. So please read them later. So today I started a little late because of almost like many of you didn't join late, but please for the next classes you come earlier so we have more time for the slides and also for the labs. So today is our first lab. The first lab, I just need you guys to install Hadoop Horton data platform for Hadoop on your system. It's not difficult because it's already installed. We just need to have a virtual platform in our system. Then you bring the already installed Hadoop in your system, and then just use it. The good thing about virtual system, anytime you make a mistake, you can just, redo everything. Just delete everything, just install it again. It doesn't take that much of time. You can also install in your system, but let's say you mess up with a part of your Windows, is much harder to fix. Like me, yesterday I messed up with some part of my Windows by mistake. Because you need to code everything. I had to code everything, and in one of the script, I just didn't type it completely. I suddenly deleted part of my Windows. So now when I want to fix this, it takes more time. But in virtual systems, it's much more safer. And the bad thing about my system is a cloud system. So if I mess up anything in Windows, fixing needs permission. So I need to contact university, get some permission to redo something. So I cannot do it everything. I have some access limitation. So the first part of the lab is installing VirtualBox. VirtualBox is a platform that lets you to install anything in it. So basically, let's say here I use VirtualBox is something like a virtual PC. So you have a blank PC, and in that PC you can install everything. For example, you can install the VirtualBox. You can install Windows. You can install Linux. You can install Hortonworks data platform. So you can consider VirtualBox makes a virtual PC for you, and inside that virtual PC you can install everything. One of them is just a Horton platform. So if you hopefully you have you follow with me. So click on the first link. This is VirtualBox, and click on. As you see, you can have VirtualBox in Windows, and you can have it in Linux, Solaris, Mac OS, so on and so forth. So, and again, for the teaching, I use the VirtualBox because for Mac, Linux, and Windows is same. So if you have issues, it's same for everyone. So I don't, and it's much easier to manage the issues. So just click on, I click on the Windows host. As you see, there is downloading on my system. I click on it. So one of your friends had a question. Oh, you're on the PPT page. Yeah, it's weird. Okay, let me just do it again. So, okay. There's some weird issues today. Okay, can you see my Chrome browser? Okay, yes. So I click on the first link. I came here to VirtualBox. And as you see here, I have Windows host, Mac OS, Linux, and Solaris. So I pick Windows. It's getting downloaded here. I just click on it. Oh. And the rest is simple, just next, 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 and you install VirtualBox on your system. Basically, again, it's just a virtual, it's like a virtual PC. Let me close it. Okay, the second link is the actual link. We install Hortonworks data platform. Basically, this data platform is a virtualized, pre-installed Hadoop platform. We just bring it inside VirtualBox. So when you bring it inside VirtualBox, you can just work with that. Click on the second link. Let's see. So here, first of all, Hortonworks is purchased by Cloudera. So now it's a part of Cloudera. Unfortunately, Cloudera also used to provide a virtual Hadoop environment. They are not supporting anymore. So we are working with Hortonworks, which is a really good one. So in the right side of the browser, you see Get Start Now. I select VirtualBox. And I please use it. I think it's much more convenient if everybody uses same platform. You can use VMware or Docker, whatever. So then click Let's Go. Then you need to provide your information. Let me just provide mine. And yes to everyone. And continue. So here you see we have Sandbox HTTP VirtualBox of 3, 2.6.5, and 2.5. For 3, I'm not sure if all of your systems can handle it. Also today, this class is kind of a virtual class, and you might have different systems. I'm not recommending Sandbox 3, might need a better, a much more powerful system. If you are happy with your own PC, you can use Hadoop number 3. If your system is very weak, use 2.5. I use the middle. I don't use the latest one or the earliest one. I just use something in the middle. And my teaching would be based on 2.6.5. And so again, hopefully, if you use this one, hopefully I can find your issues and solve it better. But it might be some issues with 2.5 or 3. I try to help you if you use either of them, but I think 2.6.5, if you choose that, it should be, you can, almost all of you can handle it. I think 2.5, you use 2.5 unless your system is old. If it's not too old, it's not too powerful, 2.6.5 is still a really good one. It's not, don't think it's a bad one, it's actually a good one. So I click on 2.6.5, and it's what I recommend for this class. As you see, now it's down, it's about 15 gigabytes. It's a really large file. So it takes about maybe half an hour here. I'm not sure how fast is your system. Let me just cancel it. One of the things, if your network is not stable, sometimes it might be some noise, and 15 gigabytes is too much of file. If you use 3 is 20 gigabytes. It's even much larger. So what can you do? You can right click on either of links, select copy link address, and use a download manager. Do you see my download manager? Let's see your friends. Yes. So I put a URL, add it here. Oh no, I already installed. So let me just, okay. And now I start download. So even if my internet gets interrupted or my power is off, I can resume the download later. Okay. So if your internet is very stable, you don't need to have a download manager. I'm using internet download manager, but there's so many other brands. You can just pick a free one and just copy the link, paste on your download manager. Again, you don't have to use this one. It's the one that I used to that, but there's so many free download manager. You download with the download manager. So if your power is off or there's any issues, you can resume download later, and it's much more manageable. So after downloading the HTTP Sandbox, Horton Data Platform, VirtualBox, just click on the downloaded file. Let me just show it to you. Okay, not this one. Okay, do you see my Oracle VMware VirtualBox Manager? Okay, good. So after you download the Horton data platform, which is like 15 gigabytes or more, this is a box that you see. Just click your VirtualBox box, automatically open it. As you see, my CPU is 4, RAM is 10 gigabytes. You can just increase the RAM. For example, I can change it to 18,000 megabytes. CPU, it should be 1. You can change it to 4. And here I'm using 3, but again, I don't teach the 3 one. I teach 2.65. Click import. And it would take a lot of time to just import and update. And so just let me cancel it for now. I'm not sure. So yeah, it just, as you see, change the CPU and increase it. So if your RAM is like 20, don't make your RAM here like 32, just less than your actual PC RAM. So after next, it takes some time to update and import everything. Look at here in my Horton box, I also installed Windows and Ubuntu. So basically VirtualBox is like a virtual PC that I can install everything. My Horton box, as you see, the base memory is 16. I use 4 CPUs. And just after just doing everything, it might take more than 1 hour. Just double click on the Hortonworks Sandbox HTTP 2.6. As you see, it might take a little bit. Then it loads your Hadoop. I think, I'm not sure you can see that. Let me just. Can you see something? It's just loading a black window. Okay, yes. So this is Horton box. Just wait a minute. Just please look at the video later because I know you cannot follow my steps because I already installed. So after 1 hour installing Guano, do you see on the black box, I have VirtualBox welcome address and SSN address. You need to, for accessing to Hadoop, you need to type the address that you see in front of welcome screen on your browser. So again, no worries, you cannot follow it. I just give you the, I give you access to the video later, but I just want to show how it looks like. So localhost. So when you type that address, you look at here, localhost 1080, that's enough. You see this screen. So one part is for dashboard, and the one for some other quick links. So this is the end of today. So I know when you launch dashboard, you might get an error. Fully, I tell you how to fix it later, but let's see. Okay. So when you click on the dashboard, you see a virtual sign-in. Just put Mario Dev for the username and password. Sign in. Oh, this time I didn't get the error, but you might get the error after installation, no worries. Okay, what you see here is a graphical interface for the Hadoop. You can do many things here, but as I said, for more advanced things, I'm not sure if you can see my, you can't. Okay. Do you see some small square on my browser? Okay. Did you see the username and password that I entered? Hopefully one of you said yes. So I give you the username and password later, but let me show it again. Dashboard. Oh, no. Do you see Maria Dev here? This is the username and password that you use. Both of those are Maria _ DEV. Okay, so okay, that's it for today. Thank you very much. Please follow the steps later.